Welcome to Math Pile Conceptual Understanding. Everything we can learn with concepts. Welcome student. This is Sharif. You're watching Math Pile. So as we know that yesterday we have done some important questions on polynomial. Just only one question. Some rules also have said that about the algebraic identities. Today we are going to be continuing the second question and third question. Today we are possibly to the two questions. Okay, first question we can go with: if alpha plus beta, if alpha and beta are the zeros of the polynomial x square plus 3x plus 6, find the value of alpha beta plus beta alpha, and second substitution alpha square plus beta square. Have you noticed that it same look like a square plus b square, right? So since we know that a square plus b square, yesterday I have already told you what is that formula of a square plus b square. A square plus b square can be written as a square plus b square can be written as a plus b the whole square minus 2ab. Since I have already yesterday posted a video, this is all the results of the identities, which is very important to apply in the some standard questions of polynomial, right? So let us start this question. The given polynomial, which is x square plus 3x plus 6. Since we know that how to split and finding the zeros, since we know that, but here if it is possible by splitting method, you can do that. Otherwise we have to use the relationship formula, sum of the zeros and product of the zeros. Through that way also we are able to find out. Okay, let us go for it. First of all, what is that? When you multiply, we should get, so coefficient of the x square multiplied by the constant. So coefficient of the x square, which is 1, multiplied by the constant, which is nothing but 6. 1 into 6, which is nothing but 6. When you multiply, we should get 6. When you add, we should get 3. So what are the possibilities of getting 6? Which is 1 6 are 6, and then 2 3s are 6, right? So in any order we can write 1 6 are 6 1s are, or 2 3s are 3 2s are. In many ways we can write 6. But here if you add 1 plus 6, it will become 7, but we need 3. So this is not a correct option. And then 2 plus 5, which is not 2 plus 3, which is nothing but 5, or 2 minus 3, which is nothing but minus 1 or plus 1, but we need 3. So we are not able to find out the zeros by splitting method. Sum of the zeros and product of the zeros we are not able to find out by this method. So we have to use the sum of the zeros and product of zeros of relationship formula only. What is the sum of the zeros? Sum of the zeros, which is nothing but minus coefficient of x divided by coefficient of x square, which is nothing but minus b by a. And what is the product of the zeros? Product of the zeros, product of zeros, which is nothing but constant divided by coefficient of x square, which is nothing but c by a, right? So through this way only we are able to find out the sum of the zeros and product of the zeros. We are not able to find out the alpha and beta by splitting method. Okay, so like this question also will come, because all the time we are not able to split and find out the two zeros alone. Okay, so now you can see that what is that coefficient of x, which is nothing but 3, that is nothing but b. Okay, this value which is nothing but b, this value which is nothing but c, and this coefficient of x square, which is nothing but a. Okay, so now we can easily apply. What is that? Minus b by a, which is equal to minus, what is b? B, which is nothing but 3. So minus 3 divided by, what is a, which is nothing but 1, which is nothing but minus 3 by 1, that is nothing but minus 3. And here c by a, what is c, which is nothing but 6, divided by, what is the a, which is nothing but 1, 6 by 1, which is nothing but 6. Okay, since we know that we have sum of the zeros and product zeros, we made it ready. Now we are going to find out the what are the things they ask us to solve. We can find the value of alpha beta plus beta alpha. They are asking. First substitution alpha beta plus beta alpha, we are going to be finding alpha beta plus beta alpha. Since you might have noticed that, you can see that product of the zeros, so this is nothing but product of the zeros. So alpha into beta and beta into alpha, both are product of the zeros only, right? Sum of the zeros, which is nothing but alpha plus beta, product of the zeros, which is nothing but alpha beta. So alpha beta value we have already known, so that we are going to be applying. Okay, alpha into beta, which is nothing but 6, plus one more alpha plus beta, that is also 6. So 6 plus 6, which is nothing but 12. I hope this is clear. So alpha beta plus alpha beta or beta alpha in any way. Anyway, when you multiply alpha beta plus beta alpha, both are same result only. In the question alpha beta plus beta alpha, this also can be written as alpha beta only. So we can write 2 times of alpha beta plus alpha beta, which is nothing but product of the zeros that we have already found, that is 6. So alpha beta is 6 plus one more alpha beta is 6, 6 plus 6 which is equal to 12. I hope this is clear. We can go to the next subdivision which is alpha square. We need to find out alpha square plus beta square. Alpha square plus beta square same like a square plus b square, right? So a square plus b square, we have already seen the identity, formation of identity through LHS to RHS, which is a square plus b square, which is equal to a plus b the whole square minus 2ab. So this can be written as alpha plus beta the whole square minus 2 alpha beta. Okay, right. So now we can easily apply what is alpha plus beta the whole square. Alpha plus beta, which is nothing but sum of the zeros, alpha plus beta, which is minus 3. So that is minus 3 whole square minus 2 into what is alpha beta, which is nothing but positive 6. That is 6 here. Okay. Now minus 3 the whole square. It is not minus 3 square, minus 3 the whole square, minus 3 into minus 3, which is nothing but 9 minus 2 6 are 12. So 9 minus 12, which is nothing but minus 3. I hope this is very clear. Okay. I have already done this identities yesterday. Kindly make sure that you have seen. Okay. Next we are going to be, okay, we'll do the second question. If alpha and beta are the zeros of the polynomial f of x, which is equal to 2x square plus 5x plus k, satisfying the relation alpha square plus beta square plus alpha beta, which is nothing but 21/4, then find the value of k. We are going to be finding the value of k, and this relation which is satisfied, okay, and this polynomial 2x square plus 5x plus k, our polynomial satisfying this relation, then find out the value of k. That is the question. The given polynomial, first of all, we can write what is the given polynomial. 2x square plus 5x plus k. This is our given polynomial. So through that only we are going to be finding alpha square plus beta square plus alpha beta, which is nothing but 21/4. We need to find out the value of k. So from this, first of all, we can find out the sum of the zeros and product of the zeros. We are not at all able to finding the zeros through splitting method because the constant is unknown, which is k. Okay, that is what we are going to be finding. So we know that sum of the zeros, which is nothing but sum of the zeros that is alpha plus beta, which is equal to minus b by a, and product of zeros alpha beta, which is equal to c by a. We can do, right, minus b by a, minus b, what is the coefficient of x square, which is nothing but a, and what is the coefficient of x, which is b, and constant, which is nothing but k, which is nothing but c. So minus b by a, what is minus b by a? B is 5, so minus 5 divided by a is 2, so minus 5 by 2, and product of the 0, which is nothing but constant divided by coefficient of x square. Constant is k, so k divided by coefficient of x square, that is a, that is 2. So sum of the zeros and product of the zeros we have already done. Now we are going to be applying in the given result. Okay, all right. So we have a relation which is alpha square plus beta square plus alpha beta, which is equal to 21/4, right? Since alpha square plus beta square, we know that yesterday we have already seen the identities, that is nothing but alpha plus beta the whole square minus 2 alpha beta plus here one more alpha beta here we have, which is equal to 21/4. And kindly notice this question is kind of important. Alpha plus beta, which is nothing but sum of the zeros that we have already found. Sum of the zeros, which is nothing but minus 5/2. But here alpha plus beta the whole square, so we need to square them. So minus 5/2 the whole square, and minus 2 alpha beta plus alpha beta, which is nothing but what? Minus 2 plus 1, which is nothing but just minus alpha beta only. So which is minus alpha beta. So here it will become minus alpha beta, right? Because minus 2 alpha beta plus alpha beta, which is nothing but minus alpha beta, minus alpha beta, what we have done, alpha beta, which is nothing but product of the zeros, that is nothing but k/2. So k/2, which is equal to 21/4. Now we have an equation form. We are able to find out the value of k. Just keep the k terms in the LHS, and rest of the things we can move to RHS to find out the value of k easily, right? So kindly notice minus 5/2 the whole square, minus into minus plus 5 square, which is nothing but 25, divided by 2 square, which is nothing but 4, which is minus k by 2, which is equal to 21 by 4. Since the space is congested, I'll do here. I'll continue here, and here you can see that minus k by 2 we can keep it in the left hand side itself, which is equal to 21 by 4, and this 25 by 4 when it goes to that side, and this kindly note this fraction is adding, so it is a positive sign here, and this fraction and k by 2 both are subtracting, so this is positive, right? The 25 by 4 which is positive, never having sign means is considered positive, and when it go to that side it will become negative 25 divided by 4. And kindly notice that this is very simple, minus k by 2, which is equal to, since the denominator is common, we can put the common denominator, 21 minus 25, which is nothing but minus 4, right? And here we can easily cancel. First of all, this negative and negative we can cancel, because both sides same sign will get positive only. So negative negative we can get 4 by 4, we can simplify, it will become 1. So this is nothing but k by 2, which is equal to 1, and this 2 when it goes to that side it will become k, which is equal to 1 into 2, which is nothing but 2. So the value of k, which is equal to 2. That's such a easy question, and this question they asked in the public exam for 3 marks. I hope you like this video. If you like this video, please do subscribe, comment and click the like button. If anybody needs this type of video, those who are studying 10th standard public exam CBSE board, you can share this video. They'll be getting useful and they'll do the exams well. Okay boys, take care. We'll see you by tomorrow with the next video.